We have 100% testing depth. So we really recommend to you to test every of the systems you buy, not every of the subsystems, every rack or module. And this can be done with this BESSentials without any additional. We looked at the maximum and minimum voltage inside of a container, which means how this is for us an indication how balanced or how aligned the cells are.
And in the white paper, we really try to estimate the financial impact of not running BESSential. Like, what if we didn't run BESSential for this project, for this container? What could have happened in terms of losses, in terms of financial losses?
Webinar, bringing factory acceptance testing to the next level. What you'll learn from this webinar today is the problem with traditional FAT and SAT methods. We'll take an in-depth case study demonstrating how BESSentials testing can save you from major financial losses. We'll also look at insights on optimizing system performance for BESS projects. We'll see the estimated industry costs for maintaining traditional FAT and SAT methods. And we'll look at how implementing BESSential in your procurement contract could save you. As an agenda for today, we'll have the webinar for 45 minutes. And then we'll have 15 minutes afterwards for open Q&A. In welcoming our speakers, I'd like to introduce to you Lutz Marowitz. Lutz is an electrical engineer with over 20 years of experience in battery testing, R&D, and algorithm development. He currently leads algorithm development at Validica Diagnostics, and he's dedicated his career to an understanding of the most critical component of the energy transition, the battery. Also welcoming Arthur Clare, Director of Technology at Sinovoltaics. Arthur supports IPPs and EPCs in deploying high-quality, reliable solar modules and energy storage systems through traceability and inspection services. He has a strong understanding of diverse technologies and key market players in this industry, and provides a detailed and thorough analysis of rapidly advancing solar and storage energy sectors. Myself, I come from a background in natural resource economics. I focus on protecting renewable energy investments, maximizing ROI on assets by applying advanced QA, traceability, and ESG diligence. And now I'll hand the presentation off to Arthur Clare.
Thank you, Joshua. And good morning, good afternoon, good evening, everyone. I am Arthur, and I'll do my best to keep you awake for today's webinar. So we'll talk about BESSential and the white papers that Lutz and I have written. But maybe to give first a bit of introduction about Sinovoltaics, about what we do, I would say that in a word, we provide factory audits and inspections at factories around the world. So not only in China, but also in Europe and in the US, India, Turkey, Southeast Asia, for renewable energy assets, meaning solar modules, energy storage system, transformers, inverters, and cables, solar mounts, for example. And we help our clients who are utilities, IPPs, project developers, and also EPCs to reduce their supply chain risk. By supply chain risk, we mean quality and traceability ESG. So with quality, we really help them to do factory audits, but also inspections of PV module and other BESS components. And where we are different as an inspection company is that we have developed innovative solutions like Selma for PV module and BESSential for BESS that we are going to develop today, making sure that we go beyond sampling and that 100% of your assets are correctly inspected. That's for quality. For traceability and ESG, we also provide ESG audits and supply chain mapping audits. And we also provide services making sure that your renewable energy assets are being correctly checked to make sure they will be cleared for US customs clearance. So that's a bit about Sinovoltaics. So now let's jump deeper into this webinar, and we have we have two questions for you. First one is, what kind of quality control do you implement today for your BSS asset? So we have, you should see, I guess, on the right of your screen, the poll being available to you now. And you have, I would say, 5 options. So nothing, I trust my supplier. You can also do qualification audit of your supplier, kind of once in a lifetime. You can also do FAT monitoring, so factory acceptance testing. You can do site commissioning, and finally, battery asset monitoring. So I'll give you a couple of seconds to check this, but we have already a lot of answers. So thanks a lot for the audience. I can see that already 1/3 of the audience replied. So thanks a lot for your activity. Okay. Give you a couple of more seconds so we can reach 50% of the audience. All right. So we have 2 main, I would say the top 3 being supplier qualification audits. Second, we have battery asset monitoring and site commissioning. I still see we have 3 answers for nothing, I trust my supplier. Maybe you will change your mind after this webinar. But thanks for your participation. Second question is, since the topic of this webinar is about BESSential, one of the most frequent questions we have is, how long does it take? And by how long will my shipment be delayed? So that's the second question we have now. How long does it take to get results after performing a BESSential test? So we have 1-2 days, 3-5 days, 1-2 weeks. We could also have written 6 months, but as you can imagine, it's not the case. So again, here, I'll give you a couple of seconds to answer this. Okay, so say most of you think it's related to, it's between 3 and 5 days. And so to get the answer of your question, you need to wait for a few extra minutes. But thank you for participating. So let's start with this webinar. First of all, we'll talk about BSS quality control today. So the first question of the poll was a bit of a spoiler. Then we'll talk about FAT limitations today. Then we'll have Lutz to talk more about BESSential service. Finally, I'll come back to discuss about the financial consequences of loose quality control for BSS, and then we will have a Q&A session. So first, BSS quality control today. So we have, as most of you do actually, factory audits being performed at the supplier. It could be at the BSS factory, it could be at the battery pack or at the battery cell factories. And here the goal is to make sure that your manufacturer processes are stable, are state-of-the-art, and that you get the best quality. Second, you have FAT, factory acceptance testing. Here, before shipment of your BESS containers, you can have either your colleagues or maybe yourself or a third party like Sinovoltaics that will go to the factory and do some tests. We're going to see which ones. Then you also have site acceptance testing, that's site commissioning. Joshua, can you let me know if you can hear me? Or Lutz?
Yes, I can hear you, Arthur.
I was saying that there is site acceptance testing, also site commissioning. So here is a test performed when you receive the BSS on site, whatever it is in the US or in Germany, Finland, whatever. You want to make sure that the BSS you have acquired are working correctly. And last but not least, you have battery monitoring. So during the operation and the lifetime of your BSS asset, 5, 10, 15, 20 years, you will use a solution like Volticas to track the performance of your BSS. So that's today the 4 key pillars of BSS quality control, I would say. Now, at Sinovoltaics, we focus a lot on factory acceptance testing. So the last step at the factory. And from our experience, we see several limitations. First one being that we need FAT should be better understood, because FAT is really composed of, say, 4 key points. First one being to do visual inspection. So of course, not only of a container, but also of the cooling system, of the battery pack, of the racks, making sure there is no scratches, damages, rust. It's really, really key here. We'll also have electrical testing. So it could be to test for the battery module voltage, for example, or to test for the distribution box voltage to make sure that commands can be well triggered. Also, we have performance testing, which is a key point. Usually, it's composed of a full charge and full discharge test of the BSS to gather data and making sure that your BSS is working well. And last but not least, safety testing. So making sure that the fire suppression system, that the smoke detector is working well. And for your information, that the single most defects that we see during FATs. To have in like 25% of the projects that we inspect, we have at least one container with a fire safety system not working, which is a bit scary if you ask me. So those are the 4 steps of BSS FAT. Now let's move to BSS FAT shortcuts. And it's all real cases we see from our experience at Sinovoltaics. First shortcut is no factory acceptance testing. When we have seen this at a couple of tier 1s, which is extremely worrying, that sometimes they just don't do any FAT. So they say, okay, so the client is going to test anyway during the site commissioning. We are in a rush, or I don't know what's the official reason, but we'll ship without testing anything because we are confident in our battery module testing, for example. But it is absolutely the biggest red flag of any quality control for BSS. Second, you have no performance testing. So meaning that the manufacturer will only do visual inspection, making sure you have your nice logo on the container, but they won't test anything else. Again, they have done battery module testing. It was working well, so there is no reason it will not work at the container level. And spoiler alerts, they are extremely wrong. Third is a trend we are seeing now in the BSS industry, especially with bigger projects, is to do sampling inspection. So if you buy even 15, 20 containers, the manufacturer will only allow you and us and will only perform FAT on a few samples, maybe 2, 3, 4 containers. And their thinking is if it's working on those samples, it should work on every container. And this is a big, big shortcut because today BSS, and for the next few years, BSS manufacturing process is really highly manual. So it's not because you have 19 containers who are pass, that the 20th container will be pass as well. So it's another big point to be really careful about, I would say, in your procurement contracts. And last but not least, limited testing. So here it's happening during the performance testing. I took this picture to really illustrate it because I found it a really nice way to explain it. It's like when you do performance testing, it's much easier to lift small weight than to lift really, really big weight. In other words, for the battery business, it's much easier to test at like 10% of the power output of your BSS than to test at the full power output. For example, if you have a 5 megawatt-hour BSS, 5 megawatt-hour BSS, some suppliers, they will only agree to test at 1 megawatt power output. So of course, it's much easier to pass any test, any thermal test, any safety test, any BMS control test if you test at 1 megawatt instead of testing at the full 5 megawatt power. So those are really the 4 BSS FAT shortcuts that we're seeing from our experience. And that's one of the main reasons why we started BESSential. But I'll leave it to Luz to explain a bit more about it.
Yes, I'm going now to share my screen. And I will, of course, also switch on the camera. So hi, everyone, also from my side. I will try to bring you a bit more into the topic of what BESSential testing actually means, and how we, as Volitica, incorporate our skills here together with Sinovoltaics to, like the title says, bring this to a next level. But before we start that, I would like to give you a short introduction to what Volitica actually is, because some of you might not know us. In our company, we have a very central vision, which also explains what we do and also why we do, for example, BESSentials. We think and we believe that this most expensive part of the energy transition, like the battery, must be used to its full or its true potential. So if the other way around, not doing that, would waste a lot of money and a lot of resources. How we came up with this, short intro on our history, like we are based in Germany, in Dresden, so on the kind of far east of Germany. And since more than 10 years, we are working with battery monitoring. I will say a few more words on that in the next slide, but like 2012, we already started at our predecessor, like the Fraunhofer Institute here in Dresden, to monitor the first electric buses in Europe. And out of that, we launched a battery monitoring platform, which was back then called EVMon. And since 2019, we started commercializing this product. And since then, on our platform right now, we have more than 1 gigawatt hour of batteries under monitoring. Under monitoring, what do we mean by that? Basically, we collect data from batteries in the market, in the field, stationary systems, also big commercial batteries on commercial vehicle, but let's talk on this topic today about stationary systems. So in principle, every lithium-ion battery is from our side supported. We use existing data, keep that in mind, this existing data point, we use it and transmit it to our cloud, to our system, and store relevant signals, and then we feed this kind of into our system. This feeding is as plug and play as possible. So our algorithms, which we have, are self-learning. We don't need lab tests for 6 months or something like that. We have here quick to start. We call it VDX engine. What we do in the cloud, and we do a systematical analysis. Of the battery quality. So continuously, we monitor with existing data without any additional hardware. We monitor your battery and feed it back to whatever you want. Probably most of you have some SCADA system running anyway, but we could also have feed it back to in a solar park management system, in a car park management system, or of course, I don't have it on the slides. We have also our own web dashboards, which we can provide you. And the product itself is divided into 4 parts. The first underlying or basic part is what we call battery essentials. This is already more or less everything what you see on the screen, like taking the data, analyzing the data, and creating KPIs out of it. And then out of these KPIs, we have several slices of our product depending on our clients. So one group of clients we think is very interested in operation and safety. So all of what we can derive out of your operation, optimizing the safety, goes into this slice. The next layer on it, like if we find issues, it might be also interesting to investigate deeper and resolve it. And last but not least, we also offer lifetime and value management. So how to extend the lifetime of the battery, how to use it financially more optimal. So extending is not only always the optimal case for a battery to make the most profit or revenue. So we also face on like optimizing the usage to maybe just keep it, but still keeping the lifetime. So once again, we use standard data, which is anyway available. No lab tests, no expensive lab tests needed. The platform configures itself, or the algorithm configures itself automatically. We have a fully integrated in SCADA integration, and of course an innovative feature scope. Now, after this introduction to the company, let's come to the topic of this webinar, BESSentials, but it's fully integrated into what I said right now. So how do we use this knowledge? How do we use this experience to help also clients with their site or factory acceptance test? So what BESSentials, what are the benefits you get out of it? First of all, Arthur already mentioned it. We have 100% testing depth. So we really recommend to you to test every of the systems you buy, not every of the subsystems, every rack or module. And this can be done with this BESSentials without any additional effort. This brings me to the next point. Arthur mentioned that this performance test is done normally on site by the manufacturer, but really no one evaluates the data. So in the end, we could say we just evaluate what is already there, but it needs to be collected and transferred to us and so on. The advantage of that is that you realize problems when it's still cheap. So really at the site of the supplier, of the manufacturer, it's not shipped, no long time in between, some service is coming or something like that. And this is already a question, an answer to one of the questions of the polls. We are quick. So after the test is performed on site, we take up to, I will come to the timeline a bit later on as well, we take only up to 48 hours to give you back our results, because we can do that because it's fully automized. You send us the data, and after 48 hours latest, normally it's earlier, 24 hours, you get back the results. And also very important is the how do we receive the data? On the previous slide, I talked about like API integration and fully automized and so on. This is not the case here. What we need is from this performance test, we need some almost standard file formats, CSV, Excel file, MATLAB file, whatever you could name here. No API integration, no cloud connection. We exchange the files as easy as possible. Even via email is fine for us, if you prefer it like that. And what is the result actually? What can you expect from our BESSential service? Well, first of all, you get this nice looking report after it, but what is the content of the report? I'm sorry, I had to grade this out. Here I cannot present you any detailed description. You get an overall summary, an overall assessment from us, from our expert to the system, where we say like everything is okay, or you should have a special focus on this topic, or you might check this, or even whatever limit is, there was a breach of some values or something. So you get an overall summary, and then you also get a detailed look where each and every KPI of each and every module or rack or subsystem is shown to you, so you can also go back to your supplier and discuss with them about our findings. So there is no hidden thing in that. We are fully transparent here. We show you what we estimate, and you can discuss. What do we estimate? Which values, which KPIs can we derive out of a performance test? So first of all, and maybe also in your heads the most important, the available capacity, the real capacity the system provides you. So you have probably in your contract some kilowatt hours, which the system should have, and we check if this is really available. We go for the round trip efficiency, and we have some resistance indications, which is also an indication of how proper the system is manufactured. We look, of course, for voltage protection anomalies like threshold violations, abnormal charging behavior or something like that. We can look for thermal behavior. We look for how balanced the system is. So are the cells, you might know that the battery system contains a lot of, up to thousands of cells. If this system is is it nicely or smoothly balanced, or are there already outliers that there are some cells not working properly? We're looking for other, summarized here as abnormal conditions, which can be very, very different. And another very important thing which we do is we do kind of peer group, we do a peer group comparison. So we follow this strong assumption that if you buy a system, every subsystem should behave the same. So also from outliers, you can figure out that something might be in one module or in one rack a bit different than in the other peers. And so we can also even look for interesting or outstanding effects which are not precisely specified in a data sheet or in a contract. It might be even that everything is within limits. I have an example afterwards for that, but it's still a suspicious behavior which can be fixed on site. How this is from the overall timeline going to happen? Like I already mentioned, that we have it within 24 to 48 hours after the performance test, you receive our results. So as every project, also we have to wait for an order here in your case. So, and after this order, we need a data sample from your side. Why data sample? Because the data quality and how we get the data from the performance test is very, very crucial for us, obviously, to derive our results. So to not have a delay when it's getting expensive in this period, we already ask you for a data sample. We check this data sample and we sign with you a document where we state all the limits what we check for, and we state the data quality. We tell you what we can derive, and you can still check back with your contracts or with the other values, and then we are fine to go. In this meantime, like in this here mentioned, up to 3 weeks after this data check, we create a data adapter on our side, because we need to import your data to feed it into our engine and to run fully automated. So we need up to 3 weeks between this data check and the ready to go for creating this data adapter. And then, let's say after the ready to go from our side, it normally takes about 1 week until on site the performance tests really start. And this is now getting the crucial point where no additional delay should be in there. So after a performance test, after 24 to 48 hours, you get the results as intermediate reports. And when all the single performance tests are done, after another week, we give you a consolidated final document where all the findings are connected together. All the results are presented in one report. But to say it clear, like already with these intermediate reports, they are in a style where you can already go back to your supplier or to the OEM, to the manufacturer, and discuss with them the results. So they are already at this stage fully transparent and reliable. And now I said I will show you some findings. So I brought to you here some examples from a really BESSential project, which we made for a stationary system, roughly a 50 megawatt hour system with 23 containers. And I can only show examples of KPIs which we derive. Here, for example, we have like one of the most important, I think, KPIs. This is the available or dischargeable energy. And as you see here in this test, everything was fine. The threshold specified was 2,180 kilowatt hours per container. And this was, very nicely fulfilled by each and every container of it. So as you see here, we have for each container a higher capacity, and behind that we also had a higher round trip efficiency than specified. So everything is fine. But still, it's maybe remarkable, it's not critical, but interesting that between these containers, although they are the same, you have a spread up to 10% of the capacity. So this is like referring to what Arthur says. This is still a highly manual process how these batteries are built. So there is a spread of 10% between these containers. They are not all the same, and you test one and you know that every other one is working. Another thing we found here, which is now a very detailed plot, we looked at the maximum and minimum voltage inside of a container, which means like how this is for us an indication how balanced or how aligned the cells are. And if you see it or not, this is not very aligned what you see here from the cells. So there's always the highest voltage is always significantly above the lowest voltage. What we in a perfectly aligned battery would expect is that both of the lines here are absolutely the same over each other. So we realized here a noticeable voltage variation between the cells, which means that although the battery, as shown before, is meeting the requirements for the available energy, there is still some energy or capacity trapped because of this effect and therefore unused. So resolving this problem would even make the battery better. But this is a clear case for us. This is not critical or above any specifications. It's a finding from our side where we bring in also our expert knowledge. And it's still interesting or kind of unexpected for a brand new system. So nothing to worry about, but this would be something where you could go back to the manufacturer and ask if he can improve on that. So far, no problems found in the system. But now I bring you the example where we, in this case, found a problem or, figured out something. So we looked at the thermal characteristics within this battery. And you see, this can be very different. And what we show here is kind of the temperature spread in relation to the power applied to the system or the charge throughput. It's maybe a bit not so obvious KPI which we use here, but this is already very helpful, or this is even very helpful. So in general, you can say if the value is low, everything is fine. If it's high, it can be an indication that it's not okay. So we detected here one module which is labeled as orange, which was outstanding of its peers. So it has more than 25% of this weighted temperature in homogeneity than its peers. This is also a peer group comparison, what we do here. So you will not find any of these values in a data sheet or somewhere else. It is just expected that everything is very aligned. And this is a clear and strong indication here for a problem in the thermal management, or it could even show a damaged cell, which then get really critical during the long time. And yeah, as just said, like it will lead to some significant performance problems or even to safety issues here. And our client went back to the manufacturer. The manufacturer was replacing the module, and as you can see in the dashed area, the problem was solved. So this value after replacing it, the value went down. Problem solved. Like no problem on site, no safety issue, just by doing this very smooth and short tests. And this was it from my side with these examples, and I give back to Arthur.
Thank you, Lutz. Okay, so let's continue a bit to dig a bit deeper about this example. And in the white paper, we really try to estimate the financial impact of not running BESSential. Like, what if we didn't run BESSential for this project, for this container? What could have happened in terms of losses, in terms of financial losses? So in our cases, because you need to come up with some examples, we consider that after the SAT, during 5 years, the battery pack will degrade, of course, faster than the others because of the temperature issue. But during 5 years, it's working normally. Like, it will not be detected by any BMS, any alarms. But so after, starting year 5, there is an alarm one day. No one knows where this is coming from, safety alarm, thermal alarm. So because the client is afraid of the of potential thermal runaway, he decides to, okay, I don't know what this is. I stop the project until I understand what's going on. So we're going to talk about this. And after, of course, when you find there is an issue and you understand what this is, you will have a claim management process. So between the client and the BSS manufacturer to replace defective components. And after, since this is a really happy ending, everything is solved and the BSS asset starts working at 100% again. So let's dig into that. So first, we focus on the accelerated degradation. So we came up with losses at around 50,000 USD, and it's because the pack will have accelerated aging due to higher temperature. So we considered 3% for that. It's coming from science, I would say. And after, given the number of cycles, the size of the project, and the average revenue per megawatt, we came up with a loss of $50,000. And it could go on for 5, 10, 15 years. And definitely what's a key finding here that we have is that even starting from there, BESSential will pay for itself. That's really the key point. Yeah, so that's for the accelerated degradation. But in our case, after we have the alarm starts ringing, and the asset owner is like, okay, I don't understand where this is coming from. Let's shut down this. I call either third party like Sinovoltaics or my owner's engineer or any consultant that can come tomorrow to my project or even today. So of course it's expensive. And we consider that it takes around 15 days to find an issue. So during those, to find the root cause of the issue, sorry. So during those 15 days, of course, the losses are exponential because it's not working for the 15 days. And so to evaluate the financial losses here, we took Gore Street average portfolio revenue value, which is at $166,250, to evaluate the financial losses of a project down for 15 days. But of course, if you are in the BSS market, you know that this average value could not mean much, because if it happens during a time where the price revenue is not great, it's good for you. But if it also happened at a time of really, really high prices, because usually the revenue is made from the top 10, 20, 30 days of the year. If it happens during that time, the revenue losses will be 10, 50 times higher than our own calculation. So this is an average value. But still, you can see that the financial losses here are becoming absolutely massive for 15 days because we reach $385,000 roughly of losses, which is a lot. Then we move to, we know what is the issue. We know it's a thermal issue from this battery pack. Now we contact the BSS manufacturer and we ask for a replacement. We ask for the warranties, and for anyone who has managed BSS assets, you know this is a really long process. So here we considered 100 days to agree on the claim with the manufacturer. And after, of course, you need to manufacture the new components, ship them to the US or to Europe or any other places on Earth. And of course, you need to redo site commissioning. So it will, of course, take a lot of time. Still, you will rack up losses because of the container, even if it's one container not being able to sell on the market. And it's a really big issue, of course. So here, for this, we are a bit shy of $200,000 in losses for claim management. And so if we summarize our losses for the exact case we have seen that Lutz explained, we could see that from accelerated aging, it was around $50,000, unplanned BSS shutdown of the whole project, $365,000, and from claim management and shutdown of the container with issue, around $200,000. So overall, we are at around $600,000 of losses because we couldn't find this issue during the FAT. And so here, I mentioned it's around 5% of the DC side cost. We consider Clean Horizon latest cost of, if I remember correctly, it's $130 per kilowatt hour. And so, of course, it will have a really major impact on your project return on investment. And I don't think anyone in this webinar can really afford that. So that's for, of course, we have seen now the financial losses on one project. Now we had this kind of interesting brainstorming. Okay, what would be the impact on the industry? Because it's only one project. So one would say, okay, so it's only one project, it's not going to be mine, and in the end, it's a small impact on the industry. So here we took McKinsey estimations from 2023 to 2030 in terms of gigawatt hour being deployed around the world. And here we considered, and from both Politica, Sinovoltaics, Lutz, and my experience, it's a really, really low value. We considered only 1% of defective containers. And so by considering the deployments in 2023, 2024 of an average container size of 3 megawatt hour, and from 2025 to 2030 with an average container size of 6 megawatt hour, because as you can all see in the market today, the size of the containers is slowly growing. So that's why we consider the 6 megawatt hour as an average until 2030. And here, so with 1% of defective BESS, it will mean that between 2023 and 2024, we have deployed 700 defective BESS, and between 2025 to 2030, we'll deploy 3,184 defective BESS. And so taking into account the financial losses that we have seen in our example, of course, it's an average value, but this really gives an interesting idea. We end up in the 2.3 billion range of revenue losses as an industry. So to be fair, I was really surprised by this. I was expecting financial loss for the industry at around a few $100 million, but we are more in the $1 billion range. And I think, again, that our analysis was quite on the safe side in terms of number of containers being impacted, financial losses per project. And we only considered, I would say, a small defect in a way that only one pack was impacting the whole project. But if you have been in the BSS industry, you know that sometimes it's like half of the containers who have degradation issue, for example. And so that's, of course, it will bring the financial losses much higher. And yeah, so we hope that you won't have any of the 3,879 defective BSS containers that we anticipated for this decade, roughly between 2023 and 2030, and that you'll use BESSential for your next project. Yeah, that's it. So if you want more information about the white paper, I think we can share it in the chat room. And after, I think now we can come back to the question.
Yeah, thank you so much, Arthur and Lutz, for the thorough breakdown of BESSential, going beyond FATs to remove all risk before shipment. Now we'll open up the floor for Q&A and begin with our first question here in the chat box. If you have more questions, do feel free to enter them in the chat and we'll be sure to address them. So looking at the first question here, it says, in short, why do we continue to use clean agent suppression systems if data and testing suggest that design factors such as cell geometry, thermal insulation, physical separation, and robust BMS are the primary means to prevent fires? Active fire suppression, on the other hand, appears to be a relatively ineffective last line of defense with significant OpEx implications.
Okay, let me take this one. So why do we continue to use clean agent suppression system? So first of all, David, thanks a lot for this very, very detailed question. You're right. I think if you start to have a bad fire, it's already too late. So the clean agent suppression system can help you, but your asset is lost, basically. I think it's way more efficient to work on preventive measures and on better cooling system for the BSS that will actually that will help you to detect battery defects, as well as preventing thermal imbalance in your system, higher temperature, for example, with better cooling system. And yeah, you're right. In the end, clean agent suppression system are important, but it's kind of a last resort in terms of issues. When you have issues, it's already too late, basically.
Thank you, Arthur. Next question. Under UL 9540 and 9540A and NFPA 855, aren't the cells, modules, containers designed with sufficient insulation to prevent catastrophic thermal runaway without suppression? Do any manufacturers rely on the cooling effect of suppression systems to prevent propagation?
So I think I replied a bit to that one as well in my previous question. Yeah, that's the key point is that when you have the thermal runaway event, it's already too late. So it's really key to focus on early detection of defect and, of course, better design of the container.
Okay, and it looks like this is another question here.
Maybe
in your should performance testing be done at factory or project site?
That's a great question. Thank you, Isaac, and I can answer for me and Lutz. I think Lutz, you can add to it after. I think the answer is both. Actually, the answer is both. You should do performance testing at the FAT and also at the SAT, at the site commissioning. It's really important. Actually, it's really important that you're able to compare containers' performances at both the factory, in both the factory setup and on your site.
I would fully agree to that. Although I hear often the question, yeah, but we can afford only one, which I think is a different discussion. Like, if I would have to decide, I would still say, like, the most money you can save if you do it at the factory site, because then it's not even shipped and then it's right in time when you can fix problematic things. But then still it's unsure if during the shipment something gets damaged. So I agree to Arthur, but I think a bit slightly more important, I don't know, Arthur, if you would agree, is the factory acceptance.
Yeah.
Like for BESSentials. Like the performance test you will need to do anyway, also for your grid operator or wherever you integrate your system in. But like to do the BESSentials slightly, I would say it helps you as a client more if you do it on the factory side.
Absolutely. Fully agree with that.
Okay, next question from Petros. Thank you, Petros. In your financial loss analysis, you consider downtime of the whole battery container? I'll repeat that first part. In your financial loss analysis, do you consider downtime of the whole battery container? And Petros goes on to ask, can't we just change the problematic pack with a spare one and keep the system running? If it is an overheating problem, most suppliers offer temperature monitoring at pack level, so the problematic pack will be identified from the beginning. Thank you, Petros.
Thank you. We consider downtime of the whole project, actually, because the issue here is that the thermal issue was not detected before. So that's why, as a safety measure, we consider that the battery owner, he wants to understand what's going on. And that's why we shut down for a few days the whole site.
And I think adding on that, like, even downtime of a few days is only going to happen if you have the replacement part like in place. So we also, like, from our other clients, we also see cases where it takes up to months to get a replacement part. So you have actually, if you have a broken pack, you need to shut down at least the container for months. So we have a very realistic case, I think, numbers in this case.
All right, thank you. Moving on to the next question from Barbara. How can I implement this? Looks like it's not in the supplier's best interest to agree with BESSential testing.
Yeah, you're right. That's why we, in addition to the white paper, we have released what we call the white paper add-on, where we provide contractual language for you to use in your next BSS procurement contract. Because I think when you are selecting your preferred BSS partner, you should in any way tackle those questions about quality control, FAT, sampling FAT, performance test. It should be considered in your BSS supplier selection. So I think it could really be used as a tool to evaluate the true quality of your supplier, because if your BSS supplier is not willing to do any tests or not to share any raw data from the FAT review, it's a huge red flag to me. But yeah, in a word, it's not in their best interest, but it should be in your best interest. So you should be able to leverage that in your contract.
Very good. We have another question here from Wilson. Are there any test or quality assurance procedures to predict SOH attenuation? Could such tests be conducted at commissioning of the project? And then the second part, from your experience, how much SOH degradation occurs between FAT and commissioning, i.e. FAT to freight site, storage, construction, commissioning? What are the typical OEM warranties for such performance degradation? Great question. Thank you, Wilson.
Well, I'm going into the SOH topic because I think it's a very battery-related question, or electrical question. To be very honest, I cannot fully answer this question because we never talked about SOH in this topic. We talked about we do a capacity estimation, which is kind of an indication of the SOH. But the SOH at factory acceptance should be 100 or even more %. So we would already flag if it's lower than that. And for sure, with just one measurement of this capacity and SOH at the factory or even at the site later on, you cannot do a prediction, because the prediction of SOH heavily depends also on the normal usage profile from day to day. So I'm pretty sure I didn't fully answer your question, but maybe you can rephrase it a bit.
Thank you, Lutz. We have another question here from Subhan. During FAT capacity test, RTE, voltage assessment, installation testing, etc., is already done by the OEM. What is the benefit of BESSential then?
Yeah, so you're absolutely right, and it's done at the container level. Where we are different is that, for example, it's a case shown by Lutz and that we present in the white paper. By only analyzing the data at the container level, we will not have been able to detect that issue. So BESSential really allows us to go much deeper in the analysis. Again, as Lutz mentioned, without extra testing time and without spending 6 months to qualify new battery cells. Mm-hmm. And it really allows us to go much deeper and analyze every battery unit, whatever it is, battery rack, battery modules, battery pack. And it can really allow us to identify other kind of defects that would otherwise been overlooked by a container only focused at the container level.
And adding one more thing, sorry, I'm always adding.
Yes.
It's independent. It's simply independent from the OEM. The assessment of the values.
That's right. All right, next question. Thank you everyone so much for putting your questions in here. We're moving quickly so that we can address everyone, but thanks again. From Moises, do you think that BESSential testing should be used hand in hand with site commissioning, or is BESSential enough?
I would say, like, I think the BESSentials is can or what we would propose should be a part of the site testing. Like, as we propose, it should be a part of the factory testing. So in both cases, our service can help to have independent and deep analysis of the battery and its functionality.
Okay, great. Thank you, Lutz. Next question from Angela. Thank you, Angela. Which is the top 5 elements with the highest failure rate that you know of? First seems to be FFS not working. So top 5 elements, I presume they're asking in testing with the highest failure rates.
Yeah, so yeah, I mentioned in the presentation, most frequent issue we found is related to fire safety system. I think that's what you mean with FFS. So how do we test that? We bring heat close and smoke close to the heat and smoking detection sensor, and it should trigger, of course, the alarm, and it should be easy to hear it, to see it that way. So that's the most frequent. After, we found also a lot of issue now during BESSential. To be honest, we find there is no BESSential analysis now which is done without any warning, or at least I would say yellow flag raised by us. So that, I would say, the second biggest concern now. Also, we have failure issue with the container itself. So when we do, for example, shower testing, so where you would shower the whole container, you will be able to see that some water is going inside the container. That's another frequent issue we find. Or other kind of issues might be with more like visual inspection of the container, like missing safety labels or scratches on the container, who are easier to manage. And finally, I would say, for more like hardware issue, to have the coating layer of the container with too thin. So you will have a much higher risk of rust during the operation of the container. So we check this. We have a small tool to evaluate the fitness of the coating layer, and it's really efficient here too. It's really important to monitor that aspect during the FAT.
That's right. Thank you, Lutz and Arthur. Next question here from David. Thank you, David. Are there other values considered with BESSential testing related to insurance, improving, upholding OEM guarantees, optimizing augmentation, preventative maintenance, etc.?
I'm not sure to fully understand the question, so let me rephrase it and I try to answer that one. So here, do you mean that do we have specific requests from insurance companies that, for example, some parameters should be tracked when implementing BESSential, so that the insurance company will back up the performance warranty of this BSS? If that's the case, then no, we analyze as many parameters as possible: temperature, voltage, capacity, as we have seen, cell voltage, temperature, and other parameters. But we don't do any differentiation between, oh, is this project has been triggered by insurance companies, or has it been triggered by a project developer? We do a full analysis for everyone.
Great. Thank you very much, Arthur. We have another quick question here from Luke. Thank you, Luke. Can BESSential work with every manufacturer or only LFP cells?
Definitely every, like NMC, NCA, LFP doesn't matter for us. I would say even more exotic cell chemistries can be tested. Like the whole, let's say, electrochemical tooling what we have on our side is developed in a very agnostic way. So it can be used with every battery with a very low effort of adapting or of parameterizing the algorithms. So yes, in short.
Very good. Let's see, we have some more questions here that we're getting to. Another one from David. Thank you, David. Can you please remind us how your assumptions of failure rates were correlated with field data or other test data about actual failure rates? His impression is that to date, failure rates downtime have been generally higher than expected by developers, IPPs, owner operators. So again, I'll just reiterate the question for us here. Can you remind us how your assumptions of failure rates were correlated with field data or other test data about actual failure rates?
Yeah, so I guess you are referring to the 1% defective BSS containers that we mentioned. It's really coming from our experience. Of course, to evaluate the industry impact of BSS non-conformities and also quality issue, we had to come up with that rate. I agree with you. I think that rate is much higher than 1%, but we also wanted to be conservative in our figure. Otherwise, you will have people that will come up with say, oh, they are just thinking 5%, let's say, of BSS containers are defective. It's much lower than that. But yeah, so we really considered all the assets we have inspected with Volitica in the past. I mean, both through BESSential and also in the past from both our companies. And yeah, we can tell you that 1% defective BSS is a conservative value, but that's the value we wanted to use, not to boast too much about the end figure of 2.3 billion, which is, I think, already big enough to trigger concerns from the industry.
Very good, thank you. Here's another question from Isa. How is it possible to do performance tests without inverter PCS?
You mean on-site or the factory? I don't know if you can quickly answer
Isa,
this.
if you want to quickly clarify in the chat here and just expand on your question, I think that would be helpful so we can answer accurately. Maybe we could assume at the factory.
Okay, so at the factory, manufacturers, they should have testing equipment to do this. If not, again, it's a huge concern. It's a huge red flag. Coming back to the FAT shortcut, how are they supposed to test the performance of their BSS containers if they don't have the equipment to do it? So your BSS manufacturers, they should have at least a way, some equipment to do it. And that's also where, coming back to what I mentioned earlier, where you can actually test how quality is truly implemented at your BSS supplier. Because if they don't have anything to test, you know they are not concerned about it, and that you can expect to have a lot of issues during site testing.
All right, that's right. Thank you. Looks like this could be our last one here. I just want to encourage everyone as we're wrapping up to submit any questions that you have into the chat. But it looks like our last one here is from Petros. You mentioned that you provide resistance indication. Do you mean internal resistances? How do you implement this without additional hardware? So another question regarding additional hardware. How do we implement resistance indication? Lutz, do you want to take this one?
I'm happy to, because it's a very nice and a very good question. We have a resistance indication where we compare, this is a very prominent example, I would say, for this peer group comparison. like we as you might already assume with your question, we cannot really estimate inside the cell the internal resistance with impedance spectroscopy or whatever. This is simply not possible, and this would be way too much effort. So we have to use the performance test, and out of this performance test and the cell level signals, we derive a resistance indication, which is like giving an indication of the, as the name says, resistance of the system, but this includes everything. Cell resistances, like the wiring, the contacts, everything inside, like is adding its own values to the resistance. So in the end, we get an overall impression of the resistance of the overall system, which then, if this is outstanding compared to peers or to some reference values, we can deeper check.
That's right. Very nice, Lutz. Thank you. I'll just encourage anyone to submit any final questions here in the chat. Otherwise, it looks like we are coming up on time. I do want to thank.
Reply any potential new questions by email as well. Of course, you can reach out to both Lutz and I, and we will gladly answer your question by email.
Sure.
That's right. Thank you, Arthur. And thank you, Lutz. And thank you, everybody, for tuning in today. We appreciate it. As Arthur mentioned, follow-ups and questions, you can reach out directly to Arthur and Lutz. You have your contact information right there. I hope everyone has a wonderful morning, day, or evening, wherever you are. And yes, thanks again. We look forward to seeing you soon on our next webinar. So take care.
Thank you very much. It was a pleasure.
Visit Sinovoltaics.com to learn more.